oftentimes the main challenge is not actually building the application itself. It's like convincing your teammates that this is actually good enough to go in front of your end users. So evaluation can be an antidote to that. And then finally, if you use evaluation the right way, I think it can be a great roadmap for making improvements to model performance. So if you have robust evaluation and granular evaluation, that can point you to what are the current opportunities to make your model or your system better. And that can help you decide your development path. And then, so the corollary of this is, if we're using evaluation for these three things, validating your model's performance, working together with your team to decide when you can go or no go, and then finding places to improve. In light of that, let's talk about some desired properties of a good evaluation. So what makes good evaluation? The first and probably most important quality of a good evaluation is it should be a number or a set of numbers that is highly correlated with the outcomes that you actually care about as a business. If it's not correlated with the outcomes that you care about, then it's not going to be a very useful metric to help you make decisions about whether to ship the model. One other thing that helps with evaluations, and this sort of cuts both ways, is in a perfect world you would have a single metric, like a single number that you can make go up or make go down, and that would be your evaluation metric. The reason why that's valuable is because machine learning as a field is kind of like the whole field has evolved over the course of decades to be really, really good at like finding different ways to make number go up or make number go down. As soon as you start getting into things that are qualitative or having many metrics, then this can fall apart. Now, in the real world, doing evaluation in a granular way is also really important. So it's helpful to have a single number that you're looking at, but it's also helpful to have many different ways of slicing and dicing that number so you can understand performance in a more granular fashion. And then finally, the third sort of desired property of a good evaluation is that it should be fast and it should be automatic. Now, not every evaluation is going to be is going to be instantaneous, and not every evaluation is going to be completely automatic because, as we'll talk about in more detail, humans still play a role here. But the faster and more automated the evaluation is, the more of a role it can play in your development process, right? So if you think about like a perfect evaluation suite, it's something that you as a developer can just run very, very quickly as you make iterations and changes that will tell you, okay, do these changes actually improve performance or do they not improve performance? And so if it's fast and reliable, that's kind of perfect evaluation. Okay, I will pause here and take questions. There's still someone who's talking and unmuted. So I've tried to mute everyone myself, but if you don't mind muting yourself as well, that'd be helpful.
I don't know what's happening here with the mute. Anyways, you can continue, Josh. No worries.
Oh yeah, no worries. Was just going to pause here and see if there's questions.
Okay, all right.
Cool. All right, I will keep going. Okay, next thing that we're going to talk about is, so we talked about like why is evaluation important, what makes a good evaluation metric or evaluation suite. Next thing we're going to talk about is like, why is this hard? Right? So I'm going to ground us a little bit in old school machine learning, right? So machine learning as of circa 12 months ago or older, the old way that this used to be done. So in the old world, we had this notion of a training distribution. So this is the data that you're going to train your model on. And then you would sample two data sets from this training distribution. You sample your training set, and you'd sample your evaluation set. The training set is the data you actually train the model on, and the evaluation set is the data you hold out to measure generalization performance. Then you can look at the difference between the performance of your model in these two sets, and that tells you how much your model is overfitting. So how much your evaluations, how much your model is like just too specific to these data points. Then you deploy your model and you look at this in production on a potentially different distribution of data. Ideally, you'd sample a test set from that production distribution as well and measure the performance on that. The difference between the evaluation set and the test set is a measure of your domain shift. So how much has your production distribution shifted away from the data you're actually able to train your model on? And then finally, on an ongoing basis, you'd measure performance on your production data. And the difference between your test set performance and your production performance is a measure of what people call drift, right? Which is how much is your production data changing over time and how is that affecting the performance of your model? So why doesn't this make sense in the LLM world? The reason this doesn't make sense in the LLM world is because let's face it, you probably didn't train your model, right? You probably didn't train your model, and that means that you probably don't have access to the training distribution. Or at the very least, you're using an open source model, and maybe you could get access to that data if you wanted to, but it's pretty impractical because it's a lot of data and it has nothing to do with the task that you're trying to solve. Then when you get into production, since we're using these pre-trained models that are trained on the whole internet, massive amounts of data, the idea of distribution shift or data drift is like endemic to the problem. The production distribution that you're evaluating your model on is always different from training, no matter what. There's no such thing as, unless you're evaluating on just random data from the internet, there's no such thing as an LLM problem if you're using off-the-shelf LLMs that doesn't suffer from distribution shift. So in traditional, the second reason why this doesn't work very well for LLMs is metrics. So in traditional ML, let's say that you're building a classifier to predict whether an image is a picture of a cat or a dog. The thing that makes this a lot easier is that we're able to compare the predictions that the model makes to the actual labels of whether this is in fact a cat or a dog, and compute metrics like accuracy that says, what fraction of the time did we get the answer correct? In generative applications, which is a lot of what folks are doing with LLMs, this is a lot harder. Right? So the output of your model might not be a label. It might be a sentence like, this is an image of a tabby cat. And if you have a label that says, this image is a photograph of a cat, how do you actually tell whether this prediction is correct or not? It's not super clear what metric you can use to distinguish between these two sentences, which both might be accurate descriptions of the image that they're describing. So it's hard to define quantitative metrics for LLMs. And then finally, even if you have a quantitative metric, another big challenge is that oftentimes we're using these LLMs, since they're so general purpose, to solve tasks across lots of different domains. And so if you have a model that is 90% accurate, let's say, on questions about different topics, but it's 95% accurate when you're asking about startups, it's only 90 or 85% accurate when you're asking about dogs or food. But if you ask questions about physics, the accuracy drops all the way down to 17%. Then is this actually a good model or not? Well, it depends, right? It's really, really hard to summarize whether this performance on this diverse set of tasks is good or not, because it depends a lot on the problem that you're trying to solve. Like if this is a chatbot for 9-year-olds who just have lots of questions about dogs and food, this is maybe a pretty good chatbot. But if you need it to answer questions about physics, this is not a very good chatbot. So to summarize, why does traditional evaluations like machine learning evaluation break down for LLMs? First, these models are trained on the whole internet, so there's always drift, and data drift doesn't really matter so much in this context. The metrics, the sort of outcomes that we're aiming for are often qualitative, so it's hard to come up with a number to measure success. And finally, we're often aiming for a diversity of behaviors, and so the goal of that we talked about before of like pointing at a single metric as the measure of quality for this model is more difficult. So how should we actually think about evaluating language models? The recipe for a language model evaluation really has like two components. The first is you need some data to evaluate the model on. So what data are we going to feed into the model to see how it responds? And then you need some metrics, some functions that you can use to measure the output of these models, maybe compared to a reference answer or maybe not, to tell quantitatively how performance is doing. So what this looks like is, you take this data set, you run one or more models on it, you compute one or more metrics on the outputs of each of those models, and you summarize this in some sort of report. So one of the kind of key things to understand about this is that if our recipe for building language model evaluations involves picking data to evaluate on and then picking metrics to run on that data to compute the number for the evaluation, then better evaluations correspond to having data that is better and metrics that are better. What does it mean for data to be better? Data is better if it is more representative of the data you're actually going to feed the model in the real world for the task that you're trying to solve. So if your data is more like your production data, that's a better evaluation data set. If it has nothing to do with your production data set, your production data, then it's not that the metrics that you compute on that are useless, but they're much less relevant to the problem that you're trying to solve. What does it mean for an evaluation metric to be better? Well, an evaluation metric is better if that evaluation metric is more predictive of the actual outcomes that you're aiming for with the product that you're building. So if the metric that you're computing, has almost nothing to do with the thing that your users are trying to do, then it doesn't matter if you are running it on the perfect data set. It's still not a very helpful sense of how well the model's doing. But if the evaluation metric is perfectly predictive of how humans would rate the outputs of this model, then that's a really good metric. And you need both of these things to be true in order to have a great evaluation set. So this is another good stopping point. I will jump back over to chat and see if folks have questions.
No questions so far, I think.
All right. Cool. So we kind of, on this previous slide, we talked about, I sort of put public benchmarks all the way in the bottom left here. So I want to talk a little bit, I want to justify that a little bit, talk about some of the challenges with using publicly available benchmarks to make decisions about language models. So let's talk through some of the different categories of publicly available benchmarks. So the first category and the most useful category is benchmarks for functional correctness. So these benchmarks, what they do is they take the output of a model and they actually run, or they use that output to try to solve a task. And so most of these benchmarks that are publicly available for functional correctness are operating on code generation tasks. The great thing about code generation is, code is like a thing that computers can run. So if you generate some code and then you run that code and it solves the task that you wanted to solve, that's a very good indication that the model is doing the right thing. But even just the code compiling or having some general properties of like correct code is a pretty decent indicator that the model is doing something that's good. So these publicly available benchmarks are actually very helpful if you are if you're doing a task that corresponds to them. So if you can do this, you should do it. The next category of publicly available benchmarks are live human evaluation benchmarks. And so the one that is kind of the most popular for this right now is called the chatbot arena. And the chatbot arena, the way that this works is they have they host like kind of two models side by side. I think I have this on the next slide actually. So they host two models side by side, and then you get to type in what you a question that you have for the models. You see both responses, and you pick the one that you prefer. And so they're crowdsourcing answers to the questions. They're crowdsourcing feedback on the responses that the different models are getting. And so this allows you to kind of stack rank the different models that are available based on the feedback from like actual people. So I think there's kind of like a common perception that human evaluation is the best way to evaluate whether language models are doing the right thing or not. We'll talk a little bit more in the next section about sort of general challenges with human evaluation. But I personally find the chatbot arena to be, probably the most helpful thing or the thing that's most correlated with my perception of model performance on most tasks. Third sort of set of publicly available benchmarks is categorized by models evaluating other models. And so this is sounds like kind of a crazy idea, but the idea is, rather than having a human say like which of these two outputs is better, instead you can just ask GPT-4, okay, which of these two outputs is better? Turns out that actually works like surprisingly well. And GPT-4 is like a pretty good evaluator of other language model outputs. So these types of evaluations, I think, are growing rapidly in popularity. They're powerful because they're very general. Anything you can prompt a model to do, you can get it to evaluate. And so I think these are going to play an increasing role. And again, in the next section, we'll talk a little bit about the limitations of them, limitations of this technique in general. Next category of publicly available benchmarks is task-specific performance. So the most popular or the most like famous versions of this are Helm and Big Bench. These are great because they're aiming to be as holistic as possible in terms of the different tasks that you might want to evaluate the language model on. And the way that they compute the evaluations is they formulate the tasks such that there's a clear right answer. So these are like decent ways to get a rough sense of comparison of different models, but they don't include the tasks that you care about as a model developer in most cases. And so, generally these benchmarks are not super useful for picking a model. And then finally, kind of the lowest quality form of publicly available benchmarks are sort of automated evaluation metrics that compare a gold standard output to the output of the model in a way that does not use language models to do that evaluation. So these metrics have been around for a long time in NLP. They're kind of falling out of favor recently because recent papers have shown that they're actually not very correlated with the way that humans would do the same evaluation. And again, Chatbot Arena is, when I'm trying to get a sense of a new model, how good it is, this is usually the first place that I'll start, in addition to just playing around with the models on my own. Okay, so what's wrong with publicly available benchmarks in general? The key issue with publicly available benchmarks is they don't measure performance on your use case. Just because, GPT 3.5 is slightly better or worse than some other model on a general benchmark does not mean that that'll be true on the task that you're trying to solve. Also, the methodology that a lot of these benchmarks use is not evolving as quickly as the rest of the field. So they, like a lot of these benchmarks, aren't using modern sort of chain of thought prompting techniques. They're often not using like in-context learning, and they're definitely not using the prompting or in-context learning or fine-tuning techniques that you're using in your application. And in addition to this, like measurement of model performance is really hard in general, which we'll talk more about in the context of building your own evaluations. And the publicly available benchmarks, although they're very carefully thought out, still have all of the measurement issues we're going to talk about in a second. All right, another good pausing point. Okay, there's a question here.
In the chat by African.
Go for it.
Yeah, so I think he's trying to talk about the data aspect of things, and I think in one of your slides you mentioned better data for evaluation, if I'm not mistaken. So he was talking about an experiment he ran, designing, training, and evaluation data sets in accordance to factorial design principles, and that was with 1.2 thousand data points and achieved 93% accuracy. So generally, what do you think about the factorial, what is it called, design principles for this sort of things? Yeah. Let me read the entire question because I'm trying to assimilate as well.
Yeah, maybe if you don't mind, whoever asked that, just kind of helping us understand what you're trying to answer here, or have us answer here. But I'll keep going.
Yeah.
So we talked about the problem of just like kind of Googling a benchmark and using that benchmark to make decisions about models. So what do you do instead? Well, what you should do as you continue to invest in a project that you're working on is build your own evaluation set and choose your own evaluation metrics that are specific to the task that you're trying to solve. So let's talk about how to do that. So the kind of key points for building your evaluation set are, you want to start incrementally. You want to use your language model to help. And then as you roll out your project to more and more users, you want to add more data from production that corresponds to the data your model's actually faced with in the real world. So starting incrementally. Usually when I'm starting out a new LLM project, I'll start by just evaluating the model in kind of like an ad hoc way. So if I was writing a prompt to try to get a model to write a short story about different subjects, I might try out a few different subjects in this prompt. Like I might try to have it write a short story about dogs or LinkedIn or hats. Then as I sort of try out these examples ad hoc, I'll find some ones that are kind of interesting in some way. And interesting might mean maybe the model does a bad job on this data, or interesting also might mean this is just another way that I think a user might use this prompt that I didn't think of before. And as I find these interesting examples, so as I try out inputs to the model that are interesting, I will organize those examples into a small data set. And then once I have that small data set, it might just be 2, 3, 5, 10 examples. Then as I make a change to the prompt, rather than going ad hoc, sort of input by input to try the model on those, instead I'll run my model on every example in the data set. And so yeah, interesting examples are ones that are hard or ones that are different. So second thing that you can do to make this process less manual is you can use your language model to help generate test cases for your language model. And so the way this works is you'll write a prompt that is focused on getting the model to sort of generate inputs to your prompt, and then you'll run that model, generate some inputs, and then add those to your evaluation data set. So there's an open source library that helps with this in the context of question answering in particular, that you can poke around to get some inspiration about how to do these data generation prompts. I'll also show you kind of how this looks in Gantry as well. This is like one of the pieces of functionality that we have. And lastly, I would say like the one caution here is that we have found that these models, that it's difficult to get models to generate like super diverse inputs. They'll generate inputs that are valid and interesting, but they won't really cover all of the possibilities that you as a human might think of. And so it's just good to be aware of that limitation as you use models for this. And then finally, probably the key point here is you shouldn't think of your evaluation data set as static. Evaluation data is something that you build over the course of your project as you encounter more and more sort of use cases and failure modes. And so as you roll this out and this interacts with more users, your team, your friends, and eventually your end users, you want to capture examples from production, like what do your users dislike? Maybe if you have annotators, what do they dislike? What does another model dislike? You might want to look for outliers relative to your current evaluation set. You might want to look at underrepresented topics in your current data set. So all these different heuristics, all sort of building up to taking production data that is interesting, so different or hard, and feeding that back into your evaluation set so that you're progressively evaluating on more and more challenging and more interesting data over time. So that's kind of the quick version of building your own evaluation set. Next thing I want to talk about is how you should think about picking metrics to run on that evaluation set. Here's a flow chart you can kind of think through as you make this decision. So first key question is there a correct answer to the problem that you're asking the language model to solve? If there is, then this problem gets a lot easier because you can use evaluation metrics like in classical ML. So if you're trying to get your model to classify sentences about cats or dogs, then you can still use accuracy as a metric. If there's no correct answer, then it's helpful to have a reference answer that you can point to. If there is, then you can use that reference answer as a way to judge whether your answer is correct, even though you're not expecting your answer to be exactly the same as the reference answer. If you don't have a reference answer, then looking for other kind of examples to guide you is still really helpful. So if you have a previous example or an example from a different version of the model that you might expect to be reasonable, you can use that. And if you have human feedback, then you can also use that as a way to evaluate models. And at the end of the day, if you don't have any of that, there's still metrics you can run on your output that, based on your task, can help get you a metric. So to expand on this a little bit, you've got your normal kind of machine learning evaluation metrics. Then you've got some metrics for matching a reference score. So again, the context here is you have an example output from a model, and then you have a prediction made by so you have an example correct answer from a human, and then you have a example that's generated by your model. And you want to compare these two things and say, like, is the model doing the same thing as the reference answer? You can do this using sort of deterministic things like semantic similarity. Like you can embed these two answers and see how close together they are. Or you can ask another LLM, like, is the answer that I know is correct and the answer that the model generated, are these two things factually consistent? So you can write a prompt to have an LLM run that evaluation. If you have two different answers, so you have one model that says this is the answer and another model that says this is the answer, you can, again, ask another language model which of these two answers is better according to some criteria. So you can write a prompt that says, okay, your job is to assess the factual accuracy of these two answers to the question. Here's the question, here's answer A, and here's answer B. Which one is more factually accurate? You can also write metrics that assess whether the output of the language model incorporates feedback from feedback given on an old output. So if you run your model and one of your friends says, "Hey, like I asked this a question about Taylor Swift, and it gave me back an answer that was about Taylor Swift's old albums, and I wanted an answer about the new albums." Well, you can write down that feedback, and then you can take the question that the user asked. You can run your new language model on that question, look at the output, and then ask an evaluation model whether the new output incorporates that feedback on which albums from your friend. And so the language model is assessing whether the new answer incorporates the feedback on the old answer. And that can be a pretty effective way to evaluate the model. And then finally, if you don't have access to any of that, then you can compute static metrics on the output of a single model. So the easiest and most deterministic way is to verify that the output has the right structure. But more interesting but harder to get right is asking the model to grade the answer, like give it a score on a scale of 1 to 5. So I want to give the model a score on a scale of 1 to 5 as to like how factually correct the answer is, for example. Okay, so I think a lot of these metrics incorporate this kind of key idea here, which is using models to evaluate other models. What you might be thinking is that sounds like kind of a crazy idea, right? Like how do we verify that the model doing the evaluation itself is actually correct? And that's true. But empirically, this is still very useful. And like a lot of papers are sort of moving in this direction for doing evaluation. So the reason why is that automated evaluation using language models can unlock more parallel experimentation. If you need to rely on humans to do your evaluation, then that's just going to really slow you down in running your experiments. You still, before you actually roll out a model into production that was only evaluated using other models, you probably still want to do some manual checks. And that'll give you more confidence that it's actually doing the right thing. More concretely, the research literature has been identifying some limitations of using language models to evaluate other LLMs. And there's really two kind of categories of criticism. The first is that there's a number of papers that have been discovering biases in the LLM evaluation of other LLMs. So some of those biases have been, if you're asking models to output a score on a scale of 1 to 5, the LLMs tend to prefer like one number over other numbers. Models tend to prefer their own outputs. So if you're asking GPT-4 to evaluate, Claude and GPT-4, it's going to be a little bit biased towards its own answers, maybe even over human answers. If you're asking a model to compare to two different answers, some research has found that the order of the answers, like which one comes first in the evaluation, actually matters. And language models also tend to prefer like kind of characteristics of the text that might not have anything to do with whether it's correct or not, like which one is longer. So there's a bunch of biases in language model evaluation. I think all of these have paths to being mitigated, but it's just something to be aware of if you're going to use this today. And then the second category of objection to this is like, okay, well, if the problem with language models, the reason why they need to be evaluated is that they're unreliable, then why are we trusting language models to do the evaluation? And so I think the way forward here is really not either human evaluation or language model evaluation, but it's a smart combination of both, where you use the best of both of these things to get great evaluations. So as a developer, you primarily interact with an auto evaluator. And the reason why you do that is because that lets you move fast, right? Like every change you make, you can auto evaluate and determine whether it's actually worth spending the money to do a human eval. But then that auto evaluation should be verified on your task. And the way that you verify that is through high quality human evaluation. So last thing I want to talk about before kind of showing you this in like a more practical setting is the role of human evaluation. So there's different like ways that people commonly collect feedback from humans on language model outputs. Probably the most common one that you'll see is just asking people to rate the answer on a score from 1 to 5. This is maybe the most common way of doing this, but it's also probably the worst. And the issue is that people are inconsistent, right? So what one person says is a 3 might be a 4 for someone else or a 2 for someone else. And that makes it really difficult to make metrics that you compute on top of these assessments reliable. To kind of combat that, a lot of the field has moved from asking people to rate individual responses to asking them to compare two responses. And so people are more reliable at saying, which of A or B is better than they are at giving A or B a score. And so this is kind of part of why, A versus B evaluations are what's typically used in reinforcement learning from human feedback. And this is how a lot of the kind of evaluation in the field is moving. This is also not without its challenges. So when people are doing A versus B evaluations, or then like one big issue is that human evaluators tend to look at surface level attributes of the outputs rather than the actual sort of factual accuracy of them. And so this is a really interesting paper called The False Promise of Imitating Proprietary LLMs, where they did kind of an assessment of this, and they found that when, there's been a lot of buzz about open source fine-tuned LLMs being close to GPT 3.5 quality. It turns out that they're close to GPT 3.5 in terms of human preference, but they're not very close in terms of like the actual factual accuracy. And so humans are kind of picking up on like how things are worded and formatted to a much larger degree than like the underlying accuracy of the statements when they do their evaluations. And so kind of one research direction that the field is moving in is moving away from just asking people to like read a whole statement and then give it a score or a comparison score, and instead asking people to give more fine-grained evaluations. So rather than looking at the entire output and saying like, is this good or is this bad? These approaches are asking humans to select a particular passage within the sentence that is irrelevant or untruthful. And some of the early research indicates that this might be a more reliable way of getting evaluations from humans. But at the end of the day, just like LLM evaluation, human evaluation is also highly limited. So the main limitations are quality, cost, and speed. The reality today is that GPT-4 writes better evaluations than most people that you hire on MTurk. So, which is like kind of a surprising and crazy fact. But I was reading somewhere, I think maybe this was a paper that came out in the past week or so, that a very large percentage of people on Turk are just using GPT 3.5 or GPT-4 to write their evaluations anyway. So maybe it's not that surprising. And with the second big challenge for quality is that unless you design your experiment really carefully, human evaluators might not measure the thing that you really care about, right? So again, like if you're just asking people for their preference, a lot of times their preference is going to be based on surface level attributes of the text, not underlying factuality. But human evaluation is also really costly and really slow, right? So this is not like the silver bullet answer for eval. And again, coming back to I think the way forward here is human verified eval, automated eval with language models. All right. Final thing I want to talk about is I want to just kind of like show you what this looks like a little bit more concretely. And so we're going to talk through like a process that you can use to evaluate language models progressively on data that looks like your data from production, using metrics that correspond to the things that you actually care about. And so the way this works is kind of analogous to test-driven development in traditional software development. So start out with getting a simple version of your model out there in production, running in the real world. Then you gather feedback on how that model is doing. You use that feedback to add to your evaluation data set, and also to iterate on your prompt or your model to try to improve performance. When you think the model is good enough, then you run a systematic evaluation using auto eval, using human eval, whatever technique makes the most sense for the stage of the project that you're in. Then if you're in a bigger company, you'll approve those changes, you'll deploy the model and start this loop over again. So I will flip over here. So let's walk through like a simple example of this. So what we're going to do is we're going to write we're going to build like a simple application to do some grammar correction. So let's write a naive prompt, like correct the grammar of the user's inputs. And then let's add the user's inputs. Okay, so this is like a naive prompt I might use for grammar correction. And so like, let me just get a quick sense check for whether this does something reasonable at all. So let's do like, this sentence has bad grammars. Then I don't know, another one, this sentence has okay grammar. Let's just make sure the model does something reasonable. Okay, so high level sense check, this seems fine, right? But the question is now like, okay, just because it worked on these two examples that I just made up on the spot, how do we know that it's actually working more generally than that? So that's where evaluation comes in. So we'll take a look at this prompt that we just wrote, and we'll run an evaluation on this. And again, the two key challenges for evaluation are where do you get the data, and then what metrics do you use, what criteria do you use to evaluate performance? And so in Gantry, our approach to both is using LLMs to help you. So we don't have any data to evaluate this on yet. So let's generate some. So I'll describe like the sentence that I want. And in this case, we want like sentences with bad grammar. So this is going to hit OpenAI API behind the scenes. And it's going to pull back, like give us some examples of sentences that have this characteristic, right? So there's like some interesting ones here. If you don't like spicy food, eyeballing this, it seems like these are pretty reasonable examples that we might want our model to perform well on. So let's create a new data set around this called evals. And then the second question is evaluation criteria. And so what we're going to do here is we're going to write like a simple prompt to describe to the model what characteristics we want the output to have. In this case, we want the outputs to be grammatically correct. And so now we have this data set and we have this evaluation criteria. So let's run this. And this will take a few seconds because we're subject to OpenAI latency, as we all are in the field these days. But what's going on behind the scenes is we're generating the outputs for that prompt template that I wrote for each of the inputs. And then we're evaluating them using the prompt that we wrote as a criteria. And so what we see here is like maybe not too surprising. The model's doing really well on these examples because these are simple examples, simple prompts, models doing fine. And so it's getting 5 out of 5 on all of them. If we want to understand why the model thinks that this is a good grammar correction, we can look at its chain of thought as well. So we can see the reasoning that the model applied to give the answer to this score. So in the real world, we'd probably do some more like validation of this model, but for the sake of this demo, I'm just going to deploy this, YOLO this into prod. And let's make this a little bit more interactive. So I'm going to drop a link here. Let me just verify that this is working. Yep. So I'll drop a link here, and this is like, you can imagine this as being the...
Just what you did as well.
Say again?
Yeah, a couple of questions I thought you might be interested in the next 8 minutes to also touch on as well.
Yeah, would love to kind of like make this more concrete with the rest of the loop. And then hopefully I'll get to the questions in like the last 5 minutes. So I dropped a link. Feel free to drop in and kind of, play around with this and, interact with this as a user and give feedback on like whether this is doing the right thing or not. I guess while folks do that, just for the sake of time, I'll just, move into kind of the next phase of this, right? Which is, we talked about evaluation data sets are not static. These are something that you should continue to build using production data as it comes in. So I have like preloaded some production data in here or some, fake production data in here. And what we see is like kind of some high level statistics on what's going on. And what we're looking for here is we're looking for examples that are interesting to add to our evaluation data set and to use to potentially make our model better, right? So we can look at all the inputs that people are sending in. Let's see if people are actually sending inputs in. Well, yeah, here are the ones that I sent in. I guess people are still working on it. But one thing that we notice here is there's inputs here that are in French. So if we zoom in on these inputs and see what the model's doing, for some of these inputs, it's translating the French to English, which is really probably not what we want, like not a characteristic that we want our model to have. So again, we're going to progressively build our evaluation set by adding these to this evaluation data set. And so we jump over to this evaluation data set. Now we have these like 10 examples that we generated as our starting point, as well as the 4 from production where our model wasn't doing the right thing. And so we can now make an improvement to our prompts to try to fix these issues. So I'll just I'll copy and paste the one that I pre-wrote for this purpose. Oh, I guess this is loading. Let me just do a little live prompt engineering. So it's let's do maintain the language. And so what you would do is you would make your changes to your prompt that you think would fix the problem that you found in production. Then you would go back, you would evaluate this new version compared to the last version, and then maybe add some additional evaluation criteria, like outputs should be in the same language as the inputs, and then rerun your evaluation. And so what will happen behind the scenes here is you'll take your new prompt and your old prompts. You'll run both of those against all of the evaluation data that you've collected. So both the data that you started with, as well as the data that you added from prod. And then you'll ask a model to compare the performance of those two versions on those inputs. And that's kind of the this sort of iterative process of building an evaluation set and evaluation criteria as you develop your model. And so that's kind of the process that I think makes the most sense for building these things going forward. So this is a good pausing point for me to answer questions.
Right, we're almost out of time, so I'll try to take the questions in order. And the first question was from Atakan, and he mentioned, would psychometric data preparation methods be helpful for evaluating LLMs?
I don't know what psychometric data preparation methods are. Would you mind expanding on those? And then happy to give it a shot.
Yeah, so please expand on it in the chat, Atakan. So the next question is from Christopher, and he asked, what are the best ways to evaluate one's fine-tuned LLMs? Are there open source tools and frameworks to do this?
Yeah, I mean, it's kind of following the same process that that I advocated here for, right? Which is like define your task, come up with some data that you think represents your task, come up with some criteria or some metrics, run the open source model on those criteria and those metrics, get a sense for performance, and then build your evaluation set over time. And Gantry is a great tool for doing that.
Great, nice. Thanks for sharing that. And this next question is from Nathan now. If you're using LLMs to make the test content, how different is it? How different can the model generating the test cases be compared to the model being tested? I think you touched on this earlier with LLMs evaluating LLMs. I don't know.
Yeah, I think that for generating the test cases, it's a little bit different because the test cases, it's a different type of issue if the test cases are biased than if the evaluation is biased. So if the evaluation is biased, then you might then even if you have the right data, you might get the wrong idea about whether the model is doing well in that data. But if you just have the wrong data, like if the data generation process is biased, then you still are able to kind of continue this iteration process, right? So the mindset should be, you're not going to have a perfect data set to evaluate your model on at any point. And it's something that you should always be improving. So I'm a lot less worried about folks using biased models to generate their initial evaluation set than I am about using biased models to create the evaluation itself.
Yeah, and still on the LLMs evaluation side of things, this question from Jose, and he asked, are GPT models like general purpose models like GPT 3.5 better at generating versus evaluating other results?
They're better at evaluating. So the mental model you should have is like, this isn't like strictly true, but at kind of first order approximation, models think like one token at a time. So if you ask a model, what is what is the answer to a specific question, then you're relying on it to have the next token be like the right answer. And so in general, in prompt engineering, like one way to get more reliable answers from models is to let them think before they answer. So, think step by step, write out your reasoning and then answer. And evaluation takes that a step further, which is that you give the model access to both the question and the full answer, and then allow it to think about whether that answer is correct or not. And so evaluation tends to be more reliable than generation for LLMs.
Right. And I think you already touched on James' question on whether you think it makes sense to fine-tune smaller LLMs to evaluate models. I think there's research in that. Could you sort of share that?
So the question is, does it make sense to fine-tune LLMs for evaluation?
Yeah, smaller. Yeah.
I think that makes sense. I do think that makes sense.
Ones, yeah. Did you have your examples of research that's been done there?
I don't have any examples of research that's being done there now, but I think people are working on it.
All right, so I think we can take 2 more questions before the workshop ends. And the first question from Atakan here is, how about giving a minimal pair where one is grammatical and the other one is ungrammatical, and asking the system to pick the ungrammatical one? Would that be a better evaluation criteria?
Well, maybe, but I think it's tricky to set that up, right? Because where do you get the grammatical and ungrammatical answer from? I think if you wanted to follow like more of evaluation best practices for this, then what you do is kind of the last step that we didn't quite get to is having a model compare 2 answers and ask which is more grammatical. So, if you made a change to your prompt, then you could ask a model like, okay, did this change improve how grammatical this was or not?
Right, makes sense. And just one more question before we hop off from Mohan, and he asks, based on your experience, apart from the human evaluator, what other suitable metrics and approach can be considered when doing annotation with LLMs?
Yeah, I think it's kind of, for anything that you can have humans annotate, you can also have LLMs annotate. I think generally speaking, unless you know what the answer is, like unless you're comparing something where it has to be exactly the same, in which case, normal metrics work well. If the right answer is ambiguous, then having LLMs do the evaluation is probably going to be better than any other metric that you're going to come up with.
Right. Okay. I just got a signal here that we can take one more question, and I think that should be the last question from Yuan. And he asks, does it make sense to ask the LLMs to evaluate their own outputs in the same prompts where it generates the MPO? What does the feedback look like?
Yeah, totally. So there is you can use a lot of these evaluation techniques in your chain to make your model outputs better. And so there's a paper called self-critique, which I think was the first, maybe the first really, at least the paper that covered that, or the first one that I'm aware of. And so you can apply the evaluation in the loop with the LLM as part of, having the model improve its own outputs. And that can work reasonably well. You can see lifts in performance. Obviously, what you're trading off is cost and latency at inference time. And so it doesn't make sense for all use cases.
Right. And, do you think any special prompt engineering needs to happen there for that to be really effective?
I think so. Yeah, I think so. It's hopefully not too much, but I think there's we've found as we've built out some of these automated evaluations that creating the evaluation prompts is how good an output that you get is somewhat sensitive to that. And so I think we need best practices to emerge, and I think that's also a place where companies like Gantry can just help the rest of the field answer those questions for everyone, and then hopefully not everyone needs to figure that out from scratch.
Great. Thank you so much, Josh. I think people are super excited about your talk. It's been a really, really comprehensive one so far. Thank you so much.
Great. Thank you. And I'll just drop a link in the chat here. If folks want to play around with the Gantry UX that I just showed, we're kind of running an alpha right now. And so I'll just drop a link here that gives everyone access to play around with it. Totally free. Just let us know what you think.
Yeah, awesome. That was super helpful. So thanks a lot, everyone. I think we can all join the other talks now. Thank you. Bye.
Great. Thanks.